This is Jody Trana with Chapter 6, Part 2 of Business Finance. At this point, you should be able to mentally identify the components that are in any given problem to determine which one of the components is missing in your problem. Make sure that you understand the difference between the present value and future value and the payments. Also, you need to remember whether you enter present value as a negative or payment as a negative. You'll have to remember when you're using Excel that you will use a decimal point when you're doing the interest rate, but when you're using the financial calculator, you will use a whole number, a percentage. Also consider that the number of periods may be different if you are compounding for a monthly time frame versus an annual time frame. We're going to do a little bit of practice identifying the components that are in a problem and the missing components of different types of time value of money problems. So be prepared to pause the video so that you can calculate the answers. You'll want to use whichever method is most comfortable for you, whether that's Excel or whether that is the financial calculator. At this point, there will be problems that will be a little bit too difficult to use the math equations that we've talked about. So you should rely on a financial calculator or Excel. The first time value of money problem is find the future value at the end of 14 years of $1,000 invested today at an interest rate of 17%. Identify the missing element and calculate the answer. Pause the video to do that. For number 1, your missing component was the future value. 14 years was the periods. $1,000 was present value, which you would enter as a negative, and the interest rate was 17% for a financial calculator, or 0.17 in Excel. Problem number 2 says, find the present value of $15,000 to be received 13 years from today if the interest rate is 8%. Of course, the present value was the missing component for this question. Problem number 3, a 5-year ordinary annuity is worth $6,000 today. Find the interest rate if the payment is $1,500. For this problem, the missing component is the interest rate. You calculate the interest rate by identifying the other components. The present value is $6,000. The payment is negative $1,500. The periods are 5, and the future value is 0. Number 4, find the future value of $10,000 in an account that compounds monthly for 3 years at 6% APR. APR is the annual percentage rate. It takes into account the interest rate and other charges such as mortgage insurance or closing costs, discount points, but all of these are considered just an additional percentage, so you would treat this 6% APR just as you would interest. So here, of course, the missing component is the future value. The $10,000 is the present value. The periods are 360, which is 3 years, at 12 months a year since it compounds monthly. The interest rate, instead of being 6%, we need to find a monthly rate, and that's calculated by taking 6% and dividing by 12. You get 0.05%. And finally, number 5. What is the future value of an annuity due of $2,000 per year for 10 years at 9%? The missing component in this problem, of course, is the future value. We need to be able to identify each of the other components. The $2,000 is the payment. The number of years is 10. The present value is 0, and the interest is 9. To get the correct answer for this problem, you will need to make sure that you calculate this as an annuity due. So that means pressing the BGN or Begin button on your financial calculator, or using the type 1 in the equation in Excel. The newest concept to discuss is called a perpetuity. A perpetuity is an annuity that has no end. It continues forever. So for example, if you had a dividend coming to you from a preferred stock, that would come to you forever. That is a payment that you would expect to receive ongoing. There are two kinds of perpetuities. One is called a level perpetuity, and that is one that stays constant forever. And the other is a growing perpetuity. This is a perpetuity where you would expect the cash amount to grow at a regular constant rate over time. Unlike the previous calculations that have some pretty complex math equations, calculating the present value of a perpetuity is fairly simple. To calculate the present value of a level perpetuity, that is one that stays constant from period to period forever, you take the payment that you are receiving on a regular basis and you divide it by the interest, and that gives you the present value. For a growing perpetuity, we take the payment at period 1 and we divide it by interest minus the growth factor. So the only trick here is to try to determine and make sure you've identified the payment at period 1. Hopefully you still have your calculator nearby. Go ahead and calculate the present value of a $90,000 level perpetuity at 9%. To calculate a level perpetuity present value, all you have to do is take the payment, which is $90,000, and divide it by the interest rate of 0.09. You'll see that the current present value of a $90,000 level perpetuity is $1 million. Now let's take a look at that same $90,000 perpetuity at 9%, but consider it having a growth rate of 5% per year. Do you remember the present value calculation? To calculate the present value of a growing perpetuity, you would take the payment at period 1 and divide it by the interest minus the growth. Here we can see the difference between a level perpetuity and a growing perpetuity. The growing perpetuity that is calculated at 9% minus a 5% growth rate gives us a much larger present value at $2,250,000.